So we had this. No, my pen's not working. This is. I know, really. I thought we would. I was hoping that you guys would have some time for bonus. You should. You should. We should still finish. I mean, unless you want to stay, and I'm happy to do all the problems like we did last time.
Yes.
So we had this, right? Okay, so we want to define. So we want to take d dx of y squared. Is this what everyone wrote? Okay, so we're taking the derivative. Whatever we do to one side of the equation, we have to do to the other. So we get 2y dy dx, and then the derivative. Remember how I had written over here earlier dx dx? That's really what this is, the derivative of x with respect to x. It's like the same thing on the top and the bottom. It basically cancels. That's how we get 1. That's another way to think of it. And then we divide by 2y on both sides. Right? So we divide by 2y. And we get dy dx is 1 over 2y. So I want to find dy dx at the point 4, 2. And I want to find dy dx evaluated at the point 4, negative 2.
So it's just the y?
Oops. Yeah.
That matters?
In this particular case, yes, that's what's happening here. Now, as you saw in the one with the circle, the one above, we had to know the x and the y coordinate to figure out the slope. Sometimes we just need to know the x coordinate. Sometimes we just need to know the, so far when we've done this in the past, we had to just know the x coordinate. So what I'm basically showing you is sometimes you just need to know the y coordinate, and sometimes you need to know both. So that's why this is useful. We have to know how to do this.
You know that you're going to have to use this when like the y is into a single power? Like when there's a y on both sides?
Right, or if you have like sine of y.
Okay.
So you get 1/4.
Like a curve of the line is like that, so there's two values of y at one point.
Whenever you have a function of y, like y to a power is one example, but you could also have ln of y or sine of y.
Why don't you use this form?
So remember, what was my formula? It was 1 over 2y, so I didn't have to plug in x at all. That was kind of irrelevant in this case. We just needed to know the y value. Think of this. Remember, this is y squared equals x. Think about it the other way around. When I had y equals x squared, and I did the derivative, I just had to plug in the x, right? You didn't need to know the y value. This is kind of like the inverse of that. Okay, next page. This one is exactly like that first example I took you through. So just the difference with this one, it's a circle with radius 5. So what would be the slope?
Same.
Okay, so I'm not going to, I guess I can write out the steps. So this is 2x, this is 2y. Yes. If the center is at the origin, okay? If the center is at the origin, then it's always going to be an x squared plus y squared. Notice the radius. We don't care. It's always end up being 0, right? So I do get dy dx is equal to negative x over y. So I want to evaluate at that point. And what do we get? So negative 3 over negative 4. Okay, so 3 over 4. Questions there? Okay, next one. So I have 2y equals x squared plus sine of y. So I want to take
Is dy dx of 2y just keep dy over dx? Because there's no outside and inside.
well, remember, you still have the inside is still your y.
So it's 2y.
It's 2 dy dx. Think about this for a moment. Remember when I would just, okay, when you had problems in the past where I would say This is just like another, let's say I gave you this. I never showed this, but really what you were doing is you were taking d dx of both sides. That's really what you were doing. It's just we never wrote it out that way. So what happens when I take the derivative of y? That's just dy dx. It's just notation. Do you recognize that? So we have been doing d dx of both sides, and this would just be 2x. So now what happens with this 2? Well, that just comes in front. So it's 2 dy dx. Is that okay with that? Does that make sense? All right, now what happens? So the next part's just going to be 2x. That's fine. Okay? So 2x. Now, imagine with the next part. We have our outside is sine. The inside is y. Remember I said, oh, erase it. Think of y as the inside. So it's going to be,
What is it?
perfect. So it's going to be cosine, keep y the same, y is the inside, times derivative of y, which is dy dx.
What do you do now?
Okay. So imagine that dy dx is just some variable. What would you do to solve for a variable if you have it on both sides? Great. Well, so we want to get this. Anything with dy dx, we want to get on the same side. We'll divide eventually. We actually have to factor it out. So I'm going to subtract cosine y dy dx to the other side. So I have this. 2 dy dx minus cosine of y.
I can write 2y prime, right?
You can write y prime equals 2x. So basically when we have two or more places where you have a dy dx involved, anything that doesn't have dy dx get on the other side. Anything that does have dy dx get on the other side. Okay, now we can't combine these because they're not quite like terms, right? This has a cosine y. So I'm going to factor out dy dx. So I have dy dx
Then you get 2x
is
over
2 minus cosine y
You did it.
equals 2x. So dy dx is going to be 2x over 2 minus cosine of y.
Oh, how do you know that it's defined at every point?
Oh, so so we found the slope. How do we know this is defined at every point?
Cosine can never be greater than 2. Greater than
Cosine.
1, sorry.
So cosine will never go beyond -1 or 1. So will the denominator ever be equal to 0?
No.
It's impossible. So cosine of y, the way I would, is it okay if I erase this stuff that I... So this is defined at every point because the denominator because the denominator is never equal to 0, since the sine of y has to be between -1 and 1. Oh, yeah, I meant cosine.
Is there a way to graph this on the calculator? Because on the calculator, you can only graph y is equal to 0, right?
You can graph it. Yeah, you could do it.
But
I mean,
how?
what do you mean?
Because on the calculator, when
Oh,
you
I
graph
see,
it,
with
it has to
cosine.
be y equal to.
I have some programs that will help us
Oh.
do that.
You wanna tell us something?
Not yet. I'll share those with you later. Okay, so here is the process. I know we just went through it, but if you're kind of a step-by-step person, so implicit differentiation, what we're going to do is we're going to differentiate both sides. So that means d dx
So this is basically just
what we just did. I'm just kind of summarizing. So what did we do? We did d dx of both sides, and then what? We want to collect, so we want to get d by dx on one side, factor out, and then solve. So usually when it says solve, that usually means divide. or, right, you're going to divide by whatever you were able to take away from the dy dx. That's what we did last time, right? We factored and then we divided.
Would you begin by factoring this one? So you would get
No.
x, y.
Okay, this one is tricky. So let's walk through this step by step. Because this one, we have a y here and here. Y is not easy to isolate, and this is a product rule. So we actually have implicit differentiation within the product rule. But then what?
Then you have x and
You
y
still have
separate.
y. I mean, you still have
I
a
mean,
product. I mean, if you wanted to factor, what do you mean, like factor out an x?
No, like
No, they want to factor like
minus y
yeah.
squared.
x minus y and then the whole thing squared.
And that way you don't have to deal with the x times y.
It's not x minus y squared though.
That would be 2x.
That would be a 2xy.
So it's
This
x
is
minus,
not easy to.
Oh.
No, there's no.
Yeah, you
No,
can't
no,
factor
it doesn't factor. That's.
Awful.
I thought you meant like factoring out of the first two terms of the second two terms.
No.
It won't make it easier. Sorry. This. Let's go through. Okay, so let me just write out dx of this whole left side. Oops. I don't know why when I'm trying to erase, it just erases everything else. The computer's doing all kinds of fun stuff today.
So just x plus y.
Okay, let's start with this, the x squared part. What's that become?
2x.
2x.
minus
Now,
1.
I'm going to just,
It's 1.
okay, be careful here. I'm going to do x times y. So, think of x times y. Think of that as u times v. So what would be the derivative if it were u times v?
It'd be 1 times y prime.
Okay, 1 times y prime.
1 times
Uh, And you know what, for right now, I'm going to just write y prime so I don't have to write dy dx. Plus,
Why are we doing 1?
Wait, we got 1.
oh wait, no, wait, we got too many derivatives here. It's 1 times y.
Why? Isn't it x times y prime plus x prime times y? Isn't it x plus...
It's derivative of the, so it doesn't matter which one we do first. If we do derivative of the first, so derivative of x, keep this one the same, keep the so now we're going to keep x times the derivative of the second, plus 2y times y prime. Let me explain this again, and then this is equal to 0. Okay, notice because it was the product rule, I put brackets around it just so we could keep everything. So we're okay with the 2x and then the minus sign. I didn't want to have to distribute the minus just yet. So if it's x times y, we're going to do derivative of 1, keep the second part the same.
Where's 1?
Derivative of x is 1, keep the y the same. Plus, now we're going to keep the x times the derivative of y. Well, that's just y
1.
prime.
It's u v
Isn't that 1?
u prime.
Isn't that 1?
Well, you don't know what the
Okay, so what's,
It's just like treating xy as like its own function.
yeah.
Using product.
And now I want to isolate the y primes. So I have 2x minus y minus xy prime plus 2y y prime equals 0. So now I want to make sure anything that has the y prime in it is on one side, and these two terms don't have y prime or dy dx. Okay, I just wanted to get used to seeing it both ways. I'm going to leave these two here since they're already on this side. And how about we move these terms with the y prime to the other side? You could do it the other way around. I really don't care. Doesn't matter. You'll get the same answer. Sometimes it'll look a little different if like your signs are switched. But I'm going to leave 2x minus y. And then I have xy prime minus 2y y prime. Are we okay with that? Okay, now we've collected all the terms on one side. Now what do we want to do? Factor out y prime. And so y prime is going to be 2x minus y over x minus 2y. If you did this the other way around, your terms would just be switched. but
It
it's
would
the
just
same.
be negative 2x.
Yeah, you could have it possibly the other way. It's fine. Okay, we want to find what is the tangent and the normal at the point negative 1, 2.
Tangent is
Okay,
just the
so
normal
tangent's
slope.
going to be just plugging in here, right?
And then it's just negative.
Okay, so go ahead and do that. So what's the tangent slope?
1.
So tangent slope is going to be 2 times negative 1 minus 2 over negative 1 minus 2 times 2. So, what? It should be negative 4 over negative 5. So 4 over, what do you mean? This is negative 2 minus 2. Negative 4. This is negative 1 minus 4, so negative 5, so you should get 4/5. That was all the hard work. Now it's the really easy part. So what's the tangent line? And what's the normal? Good. Oops. I have to fix that. Okay, how are we doing? Okay.
What's the next one? Looks really.
Let's do example. Wait, do I have? Tomorrow's a review day, right?
Yeah.
Okay. Oh, we don't have class tomorrow? It's the next day?
Oh, it's Wednesday. Yeah.
Okay. Let's do this one. Well, the last page I'll show you. The last page is actually just more chain rule examples and rational powers, which we've already been practicing with. So really this is the last new information that we need to cover. And then I'll stay and do homework problems and things with you guys. Okay, so here's what we want to do. We want to find the second derivative. So we have to find the first derivative first. So let's do
How do you know it's a second derivative?
D
Like, I don't know
squared
what
is
D squared
equal
y.
to the second derivative.
this. So this notation
Okay.
is y double prime. That's the second derivative.
So you have to find y prime and then take the prime of that, basically.
You'll see. Now it's a little more complicated. Sorry. It's a great way to start your Monday morning. Okay, what's the left side going to look like?
2y
So 2y
dy dx plus 2 dy dx.
Let me pause there. Questions? Are we okay on that? Okay, now the right side is going to be 2. Right? Because that was with respect to x. The constant goes away. Next step. Okay, so we're going to... Oh, we can also get rid of the 2's. You'll see when I factor out dy dx. So when I actually write dy dx, are we okay if we simplify it by 2 at the same time?
Yeah.
1 over 1 plus y plus 1.
Do you do quotient rule? Yeah.
Or you could do y plus 1 to the negative 1. Okay, so we want to take this answer and we want to take its derivative. Okay, so we're taking the derivative of the derivative. Following? So here, let me write it out.
When you do the derivative of y, you're going to get...
So we're doing d dx of dy dx, and we're doing d dx of 1 over y plus 1. Now, this is just notation. So when I do the derivative of this, that's where this notation comes in. It's the second derivative with respect to x.
Just write.
You want to write y double prime? Go for it. You want me to write y double prime?
Yes, please.
Okay. Now, how do I do the derivative of 1 over y plus 1? Okay, I could do quotient rule, or I could do y plus 1 to the negative 1 and do chain rule. Let's do chain rule. Let's do chain rule because I think it's good practice. So So let me just write it over here, y plus 1 to the negative 1. Okay, so when I do the derivative, we're going to do the derivative of the outside, so the negative 1, keep the inside the same, to the negative 2, times, what's the derivative of the inside? And the 1 goes away, right? The derivative of y is your dy dx. The plus 1 is 0.
Wait, do you have to?
Okay, hold on.
You divide.
If it were y squared, it would be 2y dy dx. Is that what you just asked? Y squared? Mm-hmm.
Wait, how is it negative 1?
I used, everyone said chain rule, so, well,
Yeah, but how
like
did you
two
get to
people
the
said
negative 2?
function, but
How did you get to the negative 2?
the derivative of the outside. Subtract 1 from the exponent.
Oh, shit.
Okay. Are we okay at this point? So what, this is where, now, we know what dy dx is. It's 1 over y plus 1.
Back in.
We plug it back in. So here, I'm going to rewrite this, okay, or not. Write negative 1 over y plus 1 squared times 1 over y plus 1. And can you combine that?
Yeah. Y plus 1.
Good. So you end up with negative 1 over y plus 1 cubed. I'll write it out as soon as it's done not responding. I said, yeah, negative 1. Listen, you can combine it however you want. You want to leave it as, you know, you can even look at dy dx here as y plus 1 to the negative 1. So if I have a negative 2 and a negative 1 power, they would combine to give us a negative 3 power, and then just rewrite it on the bottom. Okay, so I'll write it here because my computer's frozen. So negative 1. So this would be y plus 1 squared. Right? And this is to the first. So I combine it. Okay, so we take dy dx, which we found previously. So here you substitute.
Oh, so we're doing that first part times that.
So you have to do this when you do the second derivative of implicit differentiation. So you do your implicit differentiation again, but when you get your dy dx, you go back to what you had previously found, substitute that in, and then see if you can simplify. So, and it combined nicely. It wasn't too bad to combine. Sometimes it is. Okay, the last page, I'll post solutions to the last page, but the last page is just more practice of that next page is more chain rule and just more power rule with rational exponents. We've already done some practice with it, so it's 10:15, so we have 20 minutes bonus. Okay, so the next 20 minutes, I'm going to look ahead at the homework assignment for tonight, so those of you that want to get a head start on the homework. Because the next class, we have a practice quiz for our actual quiz. Which
Practice quiz for the quiz. I like that.
I don't always do practice quizzes. I always do practice tests, but I don't always do practice. No, I don't. I never grade my quiz. And in fact, do I have it with me? I have. Do I have it with me? I don't have it with me. I'll bring it on Wednesday. If you want it early, you can come see me. I have them already printed and ready.
Quickly go see if my site teacher